Hello friends, I am Anirban. I am back with the solutions of the first assignment, the assignment which you were supposed to solve after watching the first week's lectures. So I'll solve the same assignment and I'll describe the how to solve it. All right. So I wish you did the best and wish you good luck. So see how to solve the questions. So the first question first. All right. So the first question asks, which of the following is a regression task? Now, as I said in the tutorial video, that a regression task is a supervised machine learning task in which the output variable is continuous valued. So you have to go down and see which of the variables are continuous, in which of the cases the output variable is continuous. So this is the correct answers are already marked, and I'll describe why the answers were chosen in that way. So the first option, predict the height of a person. So clearly the height of a person can take, so the target variable is height over here, okay, and I'll mark in a different color. So this is what is of importance to me. Okay, cool. So height is my target variable over here. And height can take any real numbered value, right, theoretically. So if we are predicting an the output variable height, then the problem is a regression problem. So this should be a regression problem. Let's talk about the other options in case you had selected them by mistake. So the next option is predict the country from which the person belongs to. So this country, now this particular variable is the output variable to be predicted, right? So country can take on a fixed number of values, and that's limited by the total number of countries in the world. All right. So the output variable is categorical in this case, it's not continuous. So this problem is not a regression problem. The next option, predict whether the price of gold will increase tomorrow. So this is a bit tricky because the price of gold obviously is a continuous number, right? But you should be aware of you should watch more closely what the problem really says, what the sentence really speaks of. So it asks whether the price of gold will increase. Okay, so rather just erase a part. So this, whether the price of gold will increase. So this thing, whether the price of gold will increase, it's a question, right? Its answer can be only two things, yes or no. So what we are supposed to predict in this question is the value of this question, the answer to this question, which can take only a fixed number of values, that is yes or no. All right. So the output of this machine learning problem is also categorical. Okay. So this is not also a regression problem. And the last one, predict whether a movie is comedy or tragedy. So you can clearly see that the output categories to be predicted, they are finite in number. There are only two output categories that can be predicted, and so this is again a classification problem because the output is categorical. So this solves the first question. Let's move on to the next page. So let's take up the next question, question number 2. So again, which of the following are classification tasks? And this is a mark all that apply question. So you have to mark all the correct answers. Find the gender of the person by analyzing his writing style. So here again you have to check which is the output variable that is getting predicted, and the output variable is gender, which can take a fixed number of values. So it's either male, female, or others. Okay, whether whatever it may be, it takes a fixed number of values. Okay, and that's why the output variable is discrete or categorical, and hence the problem is a classification problem. Predict the price of a car based on the engine power mileage. So in this option, price of car, this is a continuous valued random variable. It can theoretically take any value, any real number. can be the value of the price of a car. So any positive real number, I'm sorry. So the price of the car is a continuous valued variable which is getting predicted by this algorithm, and hence this problem is a regression problem, not a classification task. Okay. Then the next option, predict whether there will be abnormally heavy rainfall tomorrow. So again this trick comes back. So here the question is whether there will be abnormally heavy rainfall tomorrow. Okay. And the answer to this question, this is what you are supposed to predict, and there can be either there can be like two possible values only, yes or no, right. So what you are trying to predict is either yes or no. So the value that is getting, the variable which has to be predicted can take up only two values, yes or no, and hence this problem is again a classification problem because the output variable is categorical. The last option says predict the number of street accidents that will happen this month. So what you are trying to predict is the number of street accidents, which can again take any number, any integer valued number, any integer value, right, positive integer value. So this is again like this does not take, there is no finite range in which, a finite set from which this value can be, the output variable, the variable can take its values, right. It can be any number, any integer, any positive integer, and hence this is again a regression task. So the answers are A and C. So these are only the pure classification problems in this case. Let's move on to the next. The third question asks which of the following are examples of unsupervised learning. So when you have been asked whether a particular problem is supervised machine learning problem or unsupervised machine learning problem, what did I ask you to think about? What did I ask you to rather ask? You have to ask what kind of input examples has been presented to the learning algorithm, right. Whether the input examples come in the form of tuples. So for supervised learning, the inputs come as pairs of input, this is, I would write input data, okay, comes as pairs of input and target. Okay. So you know the target values, this target value is important for supervised learning. Okay. So you know the input and the target, you know the true answers, the targets are the true answers, right. So this happens in supervised, but in unsupervised, so when this becomes unsupervised, the target values are not present. Okay. The target values are missing, you are only given presented with the input values, the input descriptions, not the target value. So you don't know the correct results beforehand. Okay. So in this question, the first answer, first option shows says group tweets based on topic similarity. All right. So you are just supposed to read the text of the tweets, and you don't know, it's not given a priori that which particular topic a particular tweet is talking about. Okay, whether it's about politics or if it's about some natural disaster or something else. It's not given a priori. You have to read the tweet and you have to like have some idea. All right. So the algorithm has been presented a huge number of these tweets and just asked to find some regularity within the data, and in the process it would like to detect the topics that were present in the tweets. All right. So as you can see that as the ground truth information has not been presented to the learning algorithm a priori. Okay. So it only has the input data in the form of tweets. It is not a supervised learning problem. Okay. So this is definitely an unsupervised learning problem. The second option is make clusters of cells having similar appearance under microscope. Okay. So and these are the keywords. Okay. So grouping is a keyword. Okay. Then clustering is a keyword. These keywords are it's most of the time these keywords go with unsupervised learning problem descriptions. Okay. So these are the clues. So whenever you're like solving the question in the exam and you're a bit confused, so we should just look for these terms, whether it's a grouping problem, it's kind of clustering problem, so it's highly probable that the problem is an unsupervised learning problem. So these are the hacks that you can use in the exam. That so what's the second option talking about? It's about clustering of cells which appear similar under the microscope. Okay. So, say you have been given a section of tissue, okay, and there are different kinds of cells over there. There are epithelial cells, there are connective tissue cells, then there are muscular cells, maybe muscle cells. These are different kinds of connective tissue. So, there are like skin cells. I will make things simple. Skin cells. So, epithelial cells are a kind of skin cells. Then there are muscle cells. Then there are fat cells. Then there are blood cells, bone cells. Okay, all of them look different. All right. So, you have been given such a slide with all of these different kinds of cells, and the task is to like cluster the cells according to their visual appearance. All right. So, how they look under the microscope, that is the defining factor in deciding your clustering. Okay. So, you do not know a priori which particular class a particular cell belongs to, but you can just, you have been given the picture and you just try to find some regularity within that image. All right. So, you do not know you have not been given the ground truth before a priori, right. You are not presented the true information about the category of a cell. All right. You are just like going about finding some regularities in data. So, this is an unsupervised learning problem. The third one is the task of filtering spam emails. So, this is like filter out spam emails. So, what are spam emails? Spam emails are the ones, are the emails that arrive in your inbox and they carry completely irrelevant information that you do not want. All right. So, that kind of emails are called spam emails, and they can be advertisements or promotions or some other kind of like there can be some malicious emails as well. So, there are automatic spam filters built into all modern email software, all right, like Gmail, Outlook, Yahoo Mail. So, all of them have automatic spam filters. So, these automatically read the content of your email and try to identify whether that email is spam or not. So, if it identifies the email to be a spam email, then it is not going to show it to you. It is just going to reject it and send it to a separate spam folder, which you can review if you like to. Okay. So, the task is to know which to automatically filter out spam emails. Now, how do spam filters train themselves? So, they start learning from your preferences, okay, because preferences are not universal. So, maybe you like a kind of certain kind of emails which try to promote products, and the spam filter won't know that a priori. So, what happens is when you start using that email client and you start like whenever you see a spam email, you start marking them as spam. Okay. So, when you mark an email as spam, it immediately the software immediately moves it to the spam folder, and it remembers that yes, this particular email is a spam email according to your judgment. All right. So, the spam filter starts learning after getting your feedback, your actions, after noting your actions. So, it only starts learning your preferences only after you click and mark an email as spam. Okay. So, and some initial data is also available, like standard data. All right. So, those can also be used, and they are all marked. So, which email is spam and which email is not spam, it's already marked. All right. So, the spam filter, while teaching itself, it sees the input data in the form of tuples in like pairs. Okay. So, it sees the content of the spam of the email and also the label along with it, whether it's spam or non-spam, a typical supervised learning scenario. All right. So, the process of spam filtering is not an unsupervised learning problem, because the spam filter learns from the supervision of the user. Okay. And this is a very valid question, right? Also, let's look at the last option. Identify the gender of online customers. All right. Now, how do this kind of systems work? This kind of system starts working along with your profile information. So, when you are making a profile on a online e-commerce website, for example, you fill in the details of your gender, right? So, it finds that yes, this particular person, so you will have a certain kind of activity on the social media platform or on the social or rather online e-commerce platform, right? For example, say Amazon.com. So that's an e-commerce website. You already went there, you filled up your profile information. So the website, it knows who you are, which gender you are, and then it starts tracking your activities on the website. All right, and now given a new customer, okay, from his activities or her activities, it tries to predict which gender the person is. Okay, and again, so this kind of learning algorithms, this kind of problem is another supervised learning problem, because the system learns from the gender information that has already been presented to it. And hope that clears your doubts. Let's move on to the next question. All right. The next question says, which of these is a categorical feature? Now, a categorical feature is a feature that can take values within a finite set. Okay, so there are a fixed number of categories, a fixed number of values from which that random variable can assume different values. Okay, for example, the weight of the person. Let's analyze these features one by one. The weight of a person. The weight of a person is not a discrete number. Okay, it's a continuous number, so it is not a categorical feature. Price of gold, it is another continuous valued random variable, a continuous feature, and so this is also not a categorical feature. Mother tongue of a person is a categorical feature, because there are a finite number of mother tongues, a finite number of languages in the world, right? The amount of rainfall in a day, again, this is measured in millimeters, right? So it is also a continuous valued random variable. This is not a categorical feature. Let's move on to the next question. The validation set is used for testing the generalization performance of a learning algorithm. So if you have already seen the tutorial class of the tutorial lecture of this week, then I have like devoted a sizable amount of time describing what generalization performance really means, and how validation set is created and it's used for tracking the generalization performance of a learning algorithm while it is getting trained, okay, or generalization performance of a model while it is getting trained. So the answer is yes, validation set indeed is used for checking the generalization performance of a learning algorithm. So this is the answer. Let's go to section 2. In section 2, the first question is, yes, which of the following functions has the highest bias? Now, bias, as again we discussed in the tutorial class and as has been described by madam in the theory session, bias in a model refers to the inherent limitations of the model, that is sheerly due to the lack of parameters and lack of enough parameters to learn the important statistics of the data. So you know that the data has a lot of variations, but your model does not have enough resources, enough learning capacity to learn all of those important variations. All right, and that's what is referred to by bias. For example, say you have a bunch of data points which are which are distributed this way, all right, and a good fit to the data would go this way, all right. However, you are trying to just fit choose blue, say you are just trying to fit a straight line, so this cannot catch this important variation within that data, all right, and this will have bias. Okay, so bias comes due to the lack of parameters, in the lack of enough parameters, in the lack of adequate parameters in your learning algorithm. So which of the following functions has the highest bias? Definitely the linear model has the highest bias, because it has the least number of parameters. So let me make things more clear. So this is how you are going to think while solving questions regarding bias and variance in the exam. Okay, so bias, so your learning model okay, your machine learning model has a certain number of parameters. Now this number of parameters, it decides how complex the model is, okay, and this number of parameters, if the number becomes too small, then the learning capacity of the model becomes small, and if it becomes too big, then the learning capacity is huge. Now bias and variance arise from the number of learning parameters, number of model parameters you have, okay. If the number of model parameters is small, okay, then your model is going to have high bias, because its learning capacity is small and it won't be able to capture important factors of variation in the data. Whereas if the number of parameters is too big, then it will have a huge amount of learning capacity. However, if you don't have enough data representing the real world, okay, with that huge learning capacity, it will try to learn a lot of the noise. It will try to fit onto the noise a lot to a great degree, okay. So you would need to feed it more and more data, so that it can have a little distraction towards noise, so that it can see more valid points than invalid points or noise, okay. So if you don't have enough training data, then the variance of the model, okay, it will be very large, all right. It will be the model with its so many parameters, so much learning capacity, it will fit onto the noise and it won't do good, all right. So if the number of parameters is high, then the model has high variance, and to control the variance, to ensure that the generalization performance is good, you have to give it a lot of data. So this is how you are supposed to approach the problem. If the number of parameters is small, then the bias is high. If the number of parameters is big, then variance is high, all right. So linear model, for linear model, the number of parameters is the least, and hence the variance is, hence the bias is the highest and variance is the least, right. The next question asks, let me clear this, we move on to the next question, just a second. Scroll down, select the pen, there we go. The next question, how does generalization performance change with the increasing size of the training set? Yes. So the more the amount of training data that you show to the learning algorithm, the better has it a picture of the real world, right. So the more amount of data you show to the system, the more it is aware of the real life situation, right. So the generalization performance is bound to increase, and in other words, if you see it from a technical perspective, the number of so the more amount of training data you show to the system, the more will be the number of valid points that the system would see, and hence the parameters of the model would be able to learn the important factors of variation in the data which are prevalent in general, all right, to a better extent, and hence it would be able to solve the problem more efficiently or in a better fashion or with better accuracy when deployed to the real world. So that's why the generalization performance will improve. The next question says, the variance in an existing model can be reduced by dash the training data. So whether by increasing or decreasing the training data. So when you have a highly complicated model with a lot of parameters, you need to show it a lot of training data. If you increase the amount of training data, the number of valid examples that the model will see also increases, and hence the variance decreases, right. So your system generalizes better. So answer is increasing. All right. The next question, yes, it's about the Occam's razor. So as has been taught in the theory session, that the Occam's razor is an example of inductive bias, right. So yeah, this is a theoretical question, not much to explain because this has already been described in the theory session. The next question is a bit interesting, all right. So I'll zoom out a little bit before showing you, so that the entire diagram can fit on the screen. There we go. Yes. So I'll first read out the question. The question says, choose the function that has the maximum variance, okay. Now you have to guess what is the number of how many parameters a particular function has, right? Because a model has a lot of variance, has high variance if the number of parameters is high. So this is a line, okay, of the sort y equal to mx plus c, right? So just 2 parameters, it has the maximum bias and minimum variance, okay. So this, if you can anticipate, is a parabola, okay. It's a section of a parabola, all right, section of a parabola, all right. So a parabola in general can be represented by ax squared, general, like this is a quadratic curve, or I won't write parabola, okay, I would write a quadratic curve. And the general expression is ax squared plus bx plus c. So there are 3 parameters over here, right, a, b and c. So here the parameters were m and c, 2 parameters. Here the parameters are a, b and c, right. So here the number of parameters has increased, and hence the variance has also increased, right. The third option, as you can see, this one is a cubic polynomial or cubic curve polynomial. So it will be of the form y equal to ax cube plus bx squared plus c x plus t, okay. So the number of parameters has increased to 4, right, a, b, c and d. So 4 parameters, so the variance is also more. So this has the maximum number of parameters. So this one has the maximum number of parameters among the given curves, okay, and hence maximum variance. So this should be the answer, all right. So this concludes the session, and we have discussed how to solve the first assignment of this course, and we have presented you the correct answers. Hope you enjoyed this video, and best of luck for the next assignment, and we will have this kind of a doubt clearance come question answering session after the deadline ends for the second assignment, okay. See you next time, bye bye, peace.